All right, well, our next unit here is kind of directly after our last unit, which is energy, and we're going to look at a specific type of energy, which is electric energy. Now, kind of with electricity, or what happens with electricity, and I think some of you have used batteries before, you would have noticed that there is a plus, there's a positive side, and there's a negative side. And what happens with electricity is that those two are separated. Now, with electricity, positive and negatives, opposites, attract each other. And so when you take them apart, it's like pulling a spring apart. And so when you release the spring or turn on your device that you're using, the negative, which is the one thing that will move, the positives don't move, the negatives do, they're electrons, they will move towards the positive. And then when they get to the positive, all their energy is used up, all that spring energy. Like I said, it's like letting go of a spring, the spring snaps. And once that spring snaps, well, all that energy is released. And that's why in a battery, what happens is your battery starts off as brand new, where all the positives are on one side, all the negatives are on the other. And as soon as you put it in something and you turn it on, the negatives travel over to the positives. And when all those negatives have traveled over to the positives, your battery is now dead because all the energy has been used up. Now, what we're going to get into is a little more terminology here is electric current. Now, current is the movement of electric charges from one place to another. As I've mentioned, that's when those negatives move towards the positives. And again, the negatives are the only thing that moves. There are electrons. So when electrons flow in the same direction, they create a direct current, as we call it. And so I have a wire here, and our current, we're going to say, is headed that way, and our current is defined by the letter I. All right, now that is our current, which is measured in what's called amperes, or just short form amps. All right, now those electrons are flowing through our wire. So there they flow, they're moving through our wire. And what they have is all these electrons have a total charge, which we call Q. Now current, the current, which is the flow of electrons, but it's a measure of it. And in fact, what the measurement is with current is that we have I is equal to how much charge flows through in a given amount of time. So if you look at the area of the wire and you just measure how much charge, that's the amount of total charge that went through. But if you count how much time it takes for that current to flow through, or that charge to flow through the wire, then that is what we call our current. So current is, again, the amount of charge that flows through the wire per amount of time. All right, now let's try some examples here. So for example, number one here, if 60 coulombs of charge, that's the measurement, by the way, of charge, is coulombs, so it has a C there. All this stuff is named after somebody, so I don't know what his first name was or her first name. I believe the duo was a guy, so it could be Francis Coulomb or John Coulomb. I'm not sure who it was, but anyways, if 60 coulombs of charge are used by a hairdryer in 12 seconds, calculate the current required by the hairdryer. All right, so again, the information that we know. First off, we know how much charge was used, 60 coulombs. All right, now a hairdryer, it was running for just 12 seconds. And what we want to know is, what current does this hairdryer require? All right, and so what I can use is that formula we just went through, where the current, electric current, is equal to Q, the amount of charge divided by time. And so I is equal to, let's see here, we got 60 on the top and 12 on the bottom. All right, and so when I take 60 and I divide it by 12, I get 5. The hairdryer requires 5 amps. So in this situation, what it was telling us is that in 12 seconds, it used 60 coulombs of charge. But if we were to continually use this hairdryer for whatever amount of time, it requires 5 amps, which means it needs 5 coulombs of charge every second. All right. So that's kind of what the measurement. Charge is telling you how much it used. Amps is telling you how much it needs to use per second. 5 amps, 5 coulombs per second. All right. It's kind of like distance and velocity, where distance is your charge, how far you traveled, and velocity is how fast you did it in. All right, example 2. If a wire has 8 amps flow through it every minute, how much charge has gone through the wire? All right, so 8 amps is the requirement. So that means that 8 coulombs of charge go in every second. But in this case, it's telling us that an 8 amp current was flowing through in 1 minute. Now that's a problem because that is not in our standard units. So we got to get it in the standard units. So it is in 60 seconds. All right. And what we want to know is what total charge went through this wire. All right. Because we know the current was 8 amps. All right. So again, I'm going to use my formula there. I is equal to Q divided by T. We know I this time, how much current is flowing through that wire. Q is what we're trying to find out here. And a T, again, is in our standard units of seconds. So it's got 60. Well, again, I have a something equaling a fraction. So I'm going to go with a fraction equaling a fraction, as I always do. And I'd always do that because I want to cross multiply here. And so if I have 1 times Q, I've got a Q. And then I have 8 times 60, which equals, let's see here, I grab my calculator, 8 times 60 gives me 480 coulombs of charge. And there we go. So again, that is just, I told you it was a short lessons today. That's just one. We'll do another one at 9:30. But again, that's current, which again is the measure of how much current or charge goes through that wire in a certain amount of time. And at 9:30, we will get into voltage. Hopefully those are words you've heard before.
Wait, Mr. Gates, I have a question.
Sure. Go ahead.
So we're coming back at 9.